Hi, this is Dr. Franklin Allaire from the University of Houston downtown. And in this video, we're going to review the 5 questions that make up quiz number 3, which focuses on Science Teaching Competencies 5 and 6. So just like the other quizzes thus far, this quiz consists of 5 multiple choice questions written in a style similar to what you're going to see in the science portion of the EC6 certification exam. Again, this particular quiz covers Science Teaching Competencies 5 and 6. Competencies 5 and 6 are the third pair of competencies in what I like to refer to as PPR for science, meaning that these competencies in particular focus on pedagogy and professional responsibilities related to teaching science, specifically in the EC6 grade levels. So just as a note that the quizzes, all of the quizzes after this one will start getting into science content, beginning with physical science content, then life science content, and finally earth and space science content. But for now, let's take a look at the questions that make up quiz number 3. So you can see here that we're in Canvas and we're looking at the first question. Question number 1 here says, in addition to standards and benchmarks, which of the following should be taken into consideration when developing and planning the science curriculum? And so we have some choices, including, and all the answer choices should be taken into consideration. The choices here in this case are things like the abilities and needs of students, students' experiences and interests, and of course, developmental characteristics and prior knowledge of students. And the fact is that all of these should be taken into consideration when planning and developing a science curriculum, and really any curriculum for that matter. Okay, so, and I don't want to say that this is always going to be the case. You never want to say always, and you never want to say never, but you know, if you're given an answer choice of all of the above, that's a definite consideration. But you also want to make sure that you are reading all of the answer choices very, very carefully. And in this case, all 3 of these answer choices, abilities and needs of students, students' experiences and interests, developmental characteristics, and prior knowledge of students. These are all great answers and things to take into consideration, which is why the answer, all of the answer choices, is the correct answer for number 1. So going on to question number 2. To make the science curriculum cognitively accessible to English language learners. Now that is becoming a sort of a passé term, just as an aside. The term that is now becoming more frequently used, particularly in research, is emergent bilinguals. So I just want to put that out there. However, you will still see ESL, English as a second language, as well as English language learners in various places across the K-12 curriculum. So as I was saying, to make science curriculum cognitively accessible to English language learners in grades K through 2, teachers use units that incorporate techniques from various foreign language methods, the use of chemicals and human specimens used by scientists, a variety of instructional strategies and sophisticated science tools, and scientific exploration and hands-on activities. So this is one of those questions that's really great for exploring test-taking strategies, because you can do some, you can narrow some things down, because some of these answers might seem really, really good, but we can definitely narrow some down. First and foremost, remember that we're talking about grades K through 2. So that's important to take into consideration here when thinking about these answers. And when you think about the fact that we're discussing grades K through 2, the use of chemicals and human specimens used by scientists definitely is not going to be an acceptable answer. So we can cross that one out. In addition, while yes, a variety of instructional strategies is a great answer, the fact that we have this second part of the answer and sophisticated scientific tools is what's really going to count this one out. okay? Because again, at grades K through 2, we're not using sophisticated science tools. We're really not, so that's really what strikes that one out. So we're left with a 50-50 chance here. Techniques from various foreign language methods or scientific exploration and hands-on activities. And both of those are really good answers, but the better answer here is going to be scientific exploration and hands-on activities. And I'm sorry, that was a really bad circle. So let me try that again here. Okay, there we go. That's much better. Okay, now you might be thinking, hey, Dr. Allaire, why not that first answer, techniques from various foreign language methods? And here's the reason why. All of you watching this video are seeking either English as a second language or bilingual certification. And you have to remember that even though the majority of our students who are seeking degrees in education and these certifications are focusing on Spanish language abilities, Houston, the Houston metro area, is one of the most, if not the most diverse city in the country, which means that you're going to hear a lot of languages other than Spanish. And bilingual and emergent bilingual strategies that you're going to be using are going to vary from language to language. So while yes, there are some similarities between the foreign language strategies and methods, the methods that you're going to be using for Spanish are going to differ for Mandarin, are going to differ from Urdu, are going to differ from Hindi, are going to differ from German or Russian or any other language that is out there being spoken in our school systems. And so that's why the scientific exploration and hands-on activities is the best answer here, because those things really transcend language ability. You put, things in front of children, regardless of the language, and they're going to be engaged. They're going to engage in this hands-on learning, these hands-on activities. This is one of the reasons why if you purchase something from, for instance, IKEA, their directions don't have words, they're just pictures. Same thing with Legos. If you purchase a Lego set, there are very few words in the instruction manual for building something in a Lego set. They rely on images, and that's because images and this hands-on aspect transcends language and the strategies and methods that you might use for addressing the needs of students who for whom that language is their native language. So going on to question number 3. Question number 3 says, Ms. Jacobs walks around the classroom and engages her students in casual conversation during an activity, making a point to ask students about their project, the choices they made in its construction, and the rationale for those choices. This could best be described as, this is going to be an informal formative assessment. So just to back up here and talk about this for a moment, okay? First of all, the difference between a formative and a summative assessment. A formative assessment is an assessment for learning. That's at least the way I tend to like to think about it. That's why, using that word formative, it's assessment for learning. It is a quick snapshot that a teacher takes of what's happening with student learning in the moment. And that allows the teacher to address questions, concerns that students might have, as well as doing course corrections. So for instance, as Ms. Jacobs is walking around the classroom, she may notice that different groups of students are making the same mistakes or have the same questions. So she can very quickly say, 1, 2, 3, eyes on me, everybody take a time out or a pause for the cause, and let's talk a little bit about what we're doing. And she can address those issues right then and there in the moment. And that's the beauty of a formative assessment. Even if it's something like a quick temperature check or a very quick quiz, true, false, using some different kinds of assessment methods. If it's something very quick, very simple, and very in the moment that allows the teacher to make adjustments and see what's happening in the classroom, that's going to be a formative assessment. And again, that's an assessment for learning. Now, a summative assessment is more of an assessment of learning. That's typically going to be a bigger assessment, a project, a portfolio, a test at the end of a unit, at the end of a topic, at the end of a semester or a grading period or a year, to gauge whether students have learned whatever it is that they need to learn in that particular unit or chapter. Again, it could be as big as a grading period, a semester, or a year. So if you think, for instance, about midterms and final exams in college, those are summative assessments. Those are big things done to gauge whether you have learned whatever it is that you're supposed to learn in that particular class in a period of time. So again, comparing that to a formative assessment, a summative assessment, again, is much bigger. It tends to be at the end, and it's an assessment of learning, as opposed to a formative assessment, which is an assessment for learning. An exit pass is something that hopefully a lot of you are familiar with, and that's something that happens maybe at the end of a class period. Again, just to gauge whether what students have gotten out of something. And an exit pass it blurs the line between a formative and a summative assessment, because even though it's taken at the end of a class period or a class meeting, it can still be an assessment for learning, because if a teacher notices that a lot of students maybe missed a particular question or have a particular misunderstanding, the next time they meet, that can be addressed. So the teacher can make a course correction. Now, going beyond the formative, summative kind of a thing, what makes this informal is, as it suggests, is that Ms. Jacobs is simply walking around and engaging students in casual conversation. She doesn't have a checklist necessarily. She's not asking set questions or anything like that. She's certainly not taking a grade as she has conversations with students. It's very informal. It's casual. It's gauging what's happening with students in the moment as they're working on this particular project. So let's take a look now at question number 4. Sticking with assessment, alternative authentic assessment such as verbal reports, laboratory practical exams, story writing, developing advertisements or brochures, constructing a concept map, creating drawings or models, or developing a play or a skit can provide a better view of students' performance in science. Why are these assessment practices effective? Okay, so it's about getting beyond paper pencil kinds of tests and quizzes, thinking about alternative, authentic performance assessment kind of things. All right. And so again, we can do a little bit of elimination here. So first of all, this answer choice, they emphasize student weaknesses. If you are doing, nothing that we do really should emphasize student weaknesses. Now, you might be thinking, well, wait a minute, Dr. Allaire, these quizzes about the science teaching competencies, these are emphasizing my weaknesses. And yes, to a certain degree, you would be correct. But the purpose of these quizzes on the competencies is to help you figure out your weak areas, so that as you prepare for the core subjects exam, specifically the science portion, you can focus your studying on those areas that you're struggling with the most. So for instance, if you do very poorly in, let's say, a physical science quiz, one of the physical science quizzes that's coming up, you know right away that when it comes time for studying, that you'll need to spend maybe a little bit more time on the physics and the chemistry, as opposed to maybe the life science if you did pretty well at those. Something else that we can eliminate here, alternative and authentic assessments. I'll be very honest, while they're a lot of fun to do, they are very exciting and definitely can be more interesting than tests and quizzes. They are not necessarily easy to collect and analyze. A lot of the things that we're going to do in our science methods classes would be considered alternative or authentic assessments, like lesson planning and practice teaching. They're fun, they're interesting, they are meaningful and impactful, but they are not necessarily easy to collect and to analyze. So we're left with two choices here. This choice here, they are summative in nature and collected using instruments approved by the state. Generally not. The state of Texas is not a huge fan of authentic assessments, especially when it comes to state-approved standardized testing. They prefer things like your certification test, multiple choice. Okay, multiple choice, true, false, something that's very, very easy to collect, easy to grade, easy to look at the data. Okay, so we're left with one choice here, and that is that alternative and authentic assessments are student-centered. They are ongoing, meaning that they can go over a period of time, and they can be broken down and collected as a part of daily instruction. So it's not one and done. It's over a period of days, maybe even a period of weeks. Think about your critter inquiry project. Think about something maybe like doing the life cycle of a butterfly or a mealworm, or growing a plant or something like that. So this is something that is an extended project. Again, it's student-centered, it's ongoing, and can be broken down over a number of days and collected as part of daily instruction. Last but certainly not least, in this quiz, in quiz number 3, question number 5, during a lesson about magnetism, a student incorrectly states that all things made of metal are magnetic. I think we can all see where this misconception comes from, because you take a magnet and you pick up a bunch of things that are metal. And so students can very easily come to a conclusion that, oh, well, then all metals are magnetic. And the truth is that not all metals are magnetic. So which of the following might be the best way to correct the student and help others with this common misconception? So we have 3 choices here. Number 1, tell them they are wrong and embarrass them in front of the class. Well, you know what? That is right out, because we never want to do something that's going to embarrass a student in front of the class. Not only does that completely destroy the safe learning environment that you are trying to create, and that you have created in your class. That's a surefire way of destroying that hard-earned safe learning environment that you've created. It creates a very antagonistic atmosphere, and I'll be very honest, there's a lot more students than there are of you, and they're going to win. So we don't want to ever do something like that. So that right there tells you that any answer choice that involves number 1 is going to be out. So ask the student and others to share what they know about magnets and what they will attract. That's a really good idea. Demonstrate and engage students in a hands-on activity exploring what is and is not magnetic. That's another great way of doing it. You could set up stations with various things made of metal. Ask students to make predictions about what they think will be attractive to the magnets rather, and have them go around and test it out to see if their predictions were correct. This also goes back to one of the previous quizzes in which we were talking about getting away from this right versus wrong answer kind of a thing. So that's a great opportunity to, first of all, get them doing some predicting, making some hypotheses based on what they might know already about magnets. And then have them test those hypotheses, test their predictions to see if they're correct, but get them to honestly report that data and get them away from this idea that if their prediction was not correct, then that's a bad thing. It's okay to be wrong, because that's how we eventually get to right. So by taking out this first strategy, if you want to call it a strategy, we can eliminate 3 of these 4 choices. And so the only choice that we are left with is the one that talks about numbers 2 and 3 only, because these are much, much better strategies to use in your class, not just from a science standpoint, but also from a classroom management standpoint, which is why it's part of this PPR for science. So that's going to do it for quiz number 3. That's all 5 questions in this quiz, and I hope you found this video to be helpful. Just a heads up with our future quizzes, because again, this is the third and final pair of science teaching competencies for what I like to refer to as PPR for science, the pedagogy and professional responsibilities for science teaching. Okay, not for science teachers, but for science teaching or teaching science. Okay, from here on out, competencies, starting with competencies 7 and 8 and going all the way to competency 18, we're going to be getting into science content, starting first with the physical sciences in science teaching competencies 7, 8, 9, and 10. And then the next 4 competencies, 11, 12, 13, and 14, will be life science, followed by competencies 15, 16, 17, and 18, which will be earth and space science. So 2 big differences in terms of the quizzes. They will still be multiple choice questions. They will still be written in a style similar to what you'll see on the science portion of the certification exam. They will still be worth 5 points apiece. But again, first of all, the difference is that they will be focusing on particular areas of science content, again, starting with the physical sciences. The other difference between these first 3 quizzes and the rest of the quizzes in this set is that we are going to be going from 5 questions per quiz to 10 questions per quiz. And that's because there is just so much science content wrapped up in these competencies that it was very, very difficult to figure out 5 questions that aligned with the content. So I have expanded these practice quizzes from 5 questions to 10 questions. Each question, because the quizzes will still be worth 5 points, each question will be worth half a point. I will still be making videos like this one that explain the content, but the videos may be a little bit longer because, again, we're expanding from 5 questions to 10 questions. Now, backing up away from those, if you have any questions about the content related to competencies 5 and 6, or any of the competencies that we've covered so far in our practice quizzes, please do not hesitate to email me or talk to me in class. I will be happy to answer any questions that you might have. Until then, I hope you found this video to be helpful, and I'll see you in class. Thanks so much for watching.